Bonsoir, je m'appelle Marc, je comprends presque 50 mots en français. Puis-je avoir l'addition? Où est le gars? Ça ne marche pas ce soir, so pardon, I'll be speaking in English tonight. I'm a developer with Elasticsearch, and tonight I wanted to talk about entity-oriented search and annotated text, which is part of entity-oriented search. So what are entities? So entities are things out there in the real world. So people, cars, houses, telephones, companies. So any object or concept out there in the real world that we can give a unique ID to, a unique identity to. So that's reality. There's all these things running around, us interacting, telephoning each other, buying things, selling things, driving things. And entity-oriented search, this is actually not a bad book, which is all about this topic. It's a free book, it's a PDF you can download over the internet. But it's actually got a lot of the concepts that I'm talking about tonight, and it goes into quite a lot of detail about entity-oriented search. So entities are the things out there in the real world running around, and documents are the things that come into our businesses. And they are our perception of the world, and it's not a very good one. So it's a very imperfect view of the outside world. So it often fails to capture these IDs of these entities out there in the real world in a reliable way. So we might often find, for example, that we have multiple documents all talking about the same person, but there's no way of linking them. We don't have a common ID or anything that links them together. So often businesses have a very poor perception of the world. And if anything, what we're trying to do with documents is to get a good model of the real world so that we understand who we're dealing with. And this is the problem. So when you have bad entity recognition in your business, you fail to spot and identify those entities that are running outside there in the real world. So you won't fully understand all of the entities that you're dealing with. And this presents a number of problems. So a large problem, for example, with insurers is that insurance fraud happens when people use multiple identities and they create businesses of crashing cars into each other, and they just create new identities and then create new insurance policies and then have more crashes, and we all end up paying more for insurance because of these people, and the insurers struggle to deal with spotting the same person because they're changing their names slightly or using slightly different addresses and things. Similarly, in a policing scenario, if you know that somebody has been spotted with a gun, for example, and you're going to stop a car, then you probably want to know that. So that does rely on you knowing which people own which cars and how they're all connected together and what risks might be associated with those people. In banking, there's a thing called KYC, which is Know Your Customer. And this is really something that banks have to deal with. Otherwise, they get fined billions of pounds or euros when they fail to spot money laundering. So there are lists of people that you should not be doing business with as a bank. And if you fail to spot the fact that you've got one of those people as a customer, then these banks can be fined billions. So KYC compliance is a big thing with banking. So what we need is a set of technologies and tools that will help us fill in the gaps and understand more about people that are running out there in the real world. And this is where we try and improve the quality of the documents that we have, which we store. And there's a couple of ways, largely speaking, that you can go about this. There's sort of automated techniques and manual techniques. So I'm going to go through all of these in this talk tonight. So we're going to talk about automated means of taking unstructured data, free text, and pulling the names of companies and people and organizations out of those texts. We're going to look at structured data. ID tagging and ID chaining is a more advanced form of entity recognition. We're also going to talk about manual efforts, how people can manually define entities using queries at query time, but also tag them at index time. So let's start with unstructured data. How many of you are familiar with named entity recognition or NER tools? All right, so quite a few of you. So you'll probably recognize, this is an example here where we have a piece of text and the named entity recognition tool has scanned that text and identified a number of people and a number of companies and a number of dates and organizations. This is what these tools try and do, is they try and spot the names of entities in text. And there are a number of technologies out there. So things like Gate or Spacy or OpenNLP, OpenNLP, basis technologies. There is a mixture of commercial and open source software here. And I've tried several of these things and I got frustrated using them with Elasticsearch. So I would find very interesting things using the graph API and the graph visualization that I helped to develop at Elasticsearch. And that would tell me interesting things like we have 80 documents where President John F. Kennedy has been co-cited in the same document with Elvis Presley. And you go, gosh, that's interesting. Tell me more about that. So when you try and drill down into these entities, it's not possible to take these structured terms or phrases like John F. Kennedy and find exactly where they were mentioned in the text of the document, because there's a breakage. When these tools spotted the fact that JFK was mentioned in the document, they put the word John F. Kennedy into the search index. And obviously those two things don't match up. John F. Kennedy is not the same as JFK. So we kind of lost sight of the structured data that we pulled out of the documents using this tool, didn't have that connection back to where it was originally found in the text. So that was my beginning of why I was frustrated with what all these tools were doing with Elasticsearch. So that's why we have this new field type called annotated text. It came in Elasticsearch 6.5, and it's a plugin which you have to install using this single command. So did you put this together, the plugin installer? Yeah. David. So when you install a plugin, thank David. And that's what it's doing here. So annotated text is just like normal text. You create a mapping and you say, here's my field name, but instead of using the type text, you just give it the type annotated text. And you can still use analyzers and all those other settings that go along with text fields, but annotated text fields allow you to smuggle extra information into your index. And you do that using this syntax. So this is an example of a piece of annotated text. So I have a field called my rich text field, and the text says, today Elastic announced. But what we've done is we've used markdown syntax around the word elastic, and we've added some extra information, which is the annotation. So we're saying that that actually is it's not elastic as in elasticated underwear, it is elastic as in Elastic Incorporated, it's a company. And you might do a similar thing with Apple. So you might mention the fact that the word Apple in this document doesn't mean the apple you eat, it means Apple the company. So this syntax, what you put in the round brackets, can be anything you like, and it ends up in the search index. And you can put multiple things in here. So you can have, for example, our stock ticker could also be a part of that, that annotation there. What happens to this text then when we index it? So we have an API called Analyze, and you can throw text at it and you can see what Elasticsearch does to it before it puts it into the search index. So I'm using that same API here to look at what it does with some annotated text. So we have that piece of text again saying today Elastic announced, and we've got this extra information in there. We can see that at position 1 in the search index we have the word today. Next to that we have the word elastic, and then after that we have the word announced. So word positions 1, 2 and 3. But if you look at word position 2, we've added some extra tokens into the search index. We've added this structured data into the very point in the text where it belongs. So we can put Elastic Incorporated company, we could put the stock symbol in there, we can put whatever we like in there, and it exists exactly the same point in the text as the free text word elastic does here. So it's anchored in the text. Feel free to ask questions as we go along, by the way. So what that allows me to do, the screen is maybe slightly clipped where you're viewing it here, is I can have a piece of structured information like this bar chart at the top giving me my top structured entities. So we have John F. Kennedy at the top there, and I could build a user interface where when I click on John F. Kennedy, we run a query over there on the right saying search for person John F. Kennedy, John space F dot space Kennedy, and use highlighting on the annotated text field. We have to use a special highlighter here called Annotated. So over there on the right hand side you'll see in blue the fact that we're using the annotated highlighter type. What that does is it matches the annotations that are hidden in the text. So actually the text of this Wikipedia document didn't use the word John F. Kennedy, it actually said the 35th President of the United States. Or it could have even said JFK, and we matched it because of the annotation that's hidden behind the text. So stuff like Wikipedia is full of this kind of information. I've actually brought it along tonight. If you want a copy of it, I have all of English Wikipedia marked up in this way, so that you can do these kind of queries, because Wikipedia is full of this kind of information. So that's how you would highlight, and we would be able to see, for example, well, where exactly was John F. Kennedy mentioned next to Elvis, and you could actually see highlighted a snippet of a Wikipedia document that says JFK and Elvis and so on. Notice also that we're not actually, when we search for John F. Kennedy, we wouldn't match JFK if it was talking about the airport, because that would use a different annotation. I said before that you could put multiple tokens into an annotation. So as well as when I took Wikipedia and I took the titles of all the Wikipedia pages, so essentially all the blue links in Wikipedia, I took the URLs and made that the annotation, the structured ID. But I also looked up some extra data from a site called DBpedia. I don't know how many people are familiar with that, but for every single entry in Wikipedia, they have an ontology. So you can look up an entity like John F. Kennedy, or in this case Dwight D. Eisenhower, and it will tell you what type of thing it is in a class hierarchy. So we know that Dwight D. Eisenhower is an office holder, and that is also a type of person, which is also a type of living thing, which is a type of thing. So I could pick whatever I want from that tree where I found Dwight D. Eisenhower and add that as extra metadata into the text or the annotations that go around my documents. So in the example below, you can see how I've treated the Wikipedia text. So we might have a piece of text that says General Eisenhower, but the annotations I've chosen to put into the index include the Wikipedia ID, Dwight D. Eisenhower, and the DBpedia type. So I know he's an office holder. That means we can start to do some more interesting things as well. Notice here that the spaces in the annotations, they are sort of URL encoded. So it's %20D is HTTP encoding for the space character. So it's just a way of escaping the text that you put into the index. So we know this piece of text is saying General Eisenhower, and we know that it's also talking about somebody who is an office holder. That now means that we can find things near strings, so we can actually use that type. So this is a query which doesn't get used a lot because span queries aren't things that end users tend to type, because it requires you to put JSON together, which is a bit of a user experience challenge, I think. Once we build a GUI that lets people do this, then they've got so much power in their fingers. It's incredible. So I can do a search for photographs, the word photographs, near the word of, and then near the word type office holder. And the documents that I've matched here are photographs of General Eisenhower and photographs of Abraham Lincoln, because those entities were marked up and annotated with their types. So we know that they are office holders or politicians. So you can imagine doing similar things, find me examples of politicians near words that are to do with bribes or corruption or money or any of these kinds of things, right? So you can get all the news articles talking about all the politicians who are doing all the dodgy things, because and you've marked up all these documents to say this is a politician. I have an example application if you're looking for something to get started with a named entity recognition tool like Spacy. That's a Python-based tool. So there's a URL on the left here, ela.st/Spacy RSS. This is just a little Python script that you give it a list of RSS news feeds, and it will download and index those, and it will run them through Spacy, and then it will annotate them. So you'll get the names of companies and places and people and all those sorts of things. So what we're seeing in this visualization here is an example application where we are looking at the things that happened in the last week. So we've got China and Hong Kong kicking off, and then towards the end of the week we see Hong Kong and London appearing together. There's documents with a vertical line over there on the right hand side that suggest that those two things are connected. And when we click on those, we can drill down to the text of the document that said the Hong Kong Justice Secretary was ambushed by pro-democracy protesters in London. So that's how the world of Hong Kong and London became connected. So if you want to know more about annotated text, then there are some links here. There's the reference documentation about how to use it, plus also a blog talking about why you would want to use it in the first place. Our own OpenNLP plugin is also annotated text capable now. So you can say, I want to output the annotations as not just structured fields called person, but also I want to annotate the original text where with these people names were found. Okay, structured data. So one of the things we're doing with structured data to try and help understand who we're dealing with out there in the real world is we'll get logged events like this one where we have IP addresses and dates and all these kinds of things. And the idea is that we can take some of this information as we're indexing it and we can look it up and say, what was the user behind that IP address at that point in time? And that will tell you that's Bob, and then you might index a document saying, this is Bob making this request. So again, it's just about knowing who you're dealing with. The ingest pipeline is getting this new support for looking up reference data in version 7.5. I can't remember if you mentioned it earlier, David. No. I don't believe it's got time-based lookups yet, but it will do at some point in the future. That's on the roadmap. But it's part of this whole idea of understanding who you're doing business with and enriching your data with the information that tells you who out there in the real world is actually the source of this data that's being sent into your business. There is more complex forms of entity IDs that I wanted to talk about. So this is really drawing on some experiences that I had before I joined Elastic. So we built systems to spot fraud and things where we didn't have what we would call strong IDs. And we used a system called entity ID chaining. And the way it works is like this. So these sorts of systems are adaptive systems that learn new synonyms all the time. So they're forever re-educating themselves about which IDs people have. And I'm going to use our own GitHub repository as an example. So we have a chap called Spencer who works for us and works on Kibana. And this is actually his first commit, going way back when, 2013. And he had a GitHub ID and he had an email address. And you can see these in the commits of every commit on GitHub. We can take the user ID and we can use that to find other commits that share that same ID. But we've discovered that there's a different email address associated with this one. So he's got two email addresses that he's used in his history of GitHub commits. But again, that's taught us something new. We've just learned he has another email address. So that's an opportunity to find more information. So we can take that email address and we can find other user IDs. So we're flip-flopping between user IDs and email addresses. When you have more than one key type, you can do this. And that kickstarts a fusion process where you can start to grow the set of IDs that you pull in around an entity. But to do this, you need more than one key type. And GitHub commits happen to have this characteristic. So if we keep walking these connections, then we start to pull out together all of the IDs that Spencer's used over the years. So this is just one person with multiple IDs. So you can see how this system learns new IDs by looking for other examples of records that contain at least one of the IDs you already have in your bag. And then you just keep growing this bag of IDs around a person. So what if your data doesn't have a strong ID, like an email address? This is an example of some real data which you can download from the Dallas Police Force. It's public data, but it's probably much like your own customer databases. You have a first name, a surname, a date of birth, a postcode, and an address, but there's perhaps no strong single ID like a passport or an email address or something like that. Well, you can make strong IDs out of weak components if you glue them together. So if you combine weak IDs into what we call compound keys, you can make a combination of a name, a zip code, and an age, in this case, glue them together and make a single key. And that's one key that can help you find things like we did with Spencer and his email addresses. If you use a different type of key, so if you combine a different type of ingredients, so if you use a different combination of fields, you now have two keys. And when you have two different types of keys, you can do this chaining process. So in this example here, we had one record here, which was a crime record relating to Cicely Perkins. I think it was the victim, not the perpetrator. This diagram on the left is the full extent of all of Cicely Perkins' alter egos, all the different IDs and synonyms associated with that one person. So if you look closely at the data, you can actually see that there's examples of Cicely spelt with an S and Cicely spelt with a C and various other different misspellings of the names. And in each case, we were able to overcome the problems with misspellings because we were using multiple keys in this ID chaining. So there are a number of systems out there that do this kind of thing. Full disclosure, the people I used to work with wound up in this company called Quantexa. They use Elasticsearch, and they recently did a podcast, which I've put a link to on this slide here. They really know their stuff when it comes to using these types of techniques to link data. It actually can get quite complex. Finally, we'll move on to what I call query time entities. So I've talked about a number of different technologies that are out there. So named entity recognition tools, ID chaining tools, things like Quantexa and Zentity and all these things. So you can go out there and you can spend a lot of money on these technologies or try and build them yourself. And the reality is they will still get it wrong. That's just technology. We work in technology. We know this, right? That's why we don't trust people to wire up our houses to the internet and things like that, because we know technology goes wrong. So this is an example from the Mueller report. So this was fed through a named entity recognition tool. And yes, we've got people like Paul Manafort and Bill Barr, but we've got three different concepts for Robert Mueller. We've got Robert Mueller, and Robert S. Mueller III. So the technology thought of these as three different people. It wasn't able to join them up. So that's where the technology fails us. And that's where us as humans have to step in and try and make up for that lack of understanding in the world. So in the graph user interface, there's actually a grouping button. So you can say, take these three things and make them one, and then it will just draw one line between Bill Barr and the various different Robert Muellers that are there. That's a start, but I think we can go a lot further than that, to be honest. So in future, I think we're going to start seeing us putting more effort and emphasis into what we call query time entities. So if I can group things together and say A or B or C are actually one thing, then that should be something that I can use as the subject of my analysis. So for example, I remember somebody sent a link round a long time ago saying, if you look on Stack Overflow or in jobs on Indeed and you contrast Hadoop and Elasticsearch, it looks like we're doing quite well. And then I was thinking, well, jobs aren't advertised with just the word Hadoop. They'll say MapR or Cloudera or whatever. So if you're going to do a fair comparison, you need to use all those terms, not just Hadoop. And that's the same with looking for people like Bob Muller and Robert Muller and all those things. You need to be able to take a bag of things which are indexed in ways that are described differently and group them together and say, I want to think of that as one thing. So draw me a line on a line chart showing that. Draw me another line showing the Elastic Stack. So I might, again, take a bunch of words, Elasticsearch logs, or Kibana or Beats, and group them together and say, that's an entity. It's an entity that I've just come up with at query time because it wasn't there in the index. And that's what I want to use as a subject of my analysis. So I think we have to live with a mix of things. Yes, we can spend money on technologies that try and fix data on the way in at ingest time, but I think we also have to think about tools and techniques to actually allow end users to deal with where the technology starts to fail and where we need to fill in some of the gaps. And that's why we're interested in things like query time entities and how we can perhaps use those in Kibana and Elasticsearch as well more effectively. That's as much as I had on the slides. I don't know if anybody's got any questions. No?